everyone, this video is going to cover graphing absolute value equations or absolute value functions. And when we think about what we've been graphing with so far, we've been graphing lines or linear equations, which frequently look something like that, and they go on infinitely in one direction. Now, absolute value equations are a little bit different because they're going to create some type of V shape where we have what we call the vertex, and then it's going to be mirroring itself in opposite directions. So frequently, this value and this value are going to be the same by the nature of what an absolute value equation or absolute value function is. So before we start graphing, we want to quickly review what absolute value means. And this is something you've probably seen a couple different times. And it's not necessarily very hard to do mathematically, but it's easy to forget. Absolute value, by definition, means distance away from zero. And if we know that the distance away from something has to be a positive, that means that absolute value makes all numbers non-negative. I say non-negative because the absolute value of 0 is still 0. So the absolute value of 3 is 3 units away from 0, so it's 3. The absolute value of negative 6 is still 6 units away, which makes it a positive 6. Absolute values of decimals, are still decimals. Absolute values of fractions are still fractions. And where we did them the most this year is when you have something like this where inside of the absolute value bars we have negative 3 plus negative 6. We have to think of it as there's also parentheses around here, which means we have to do all of this first. Then we take the absolute value of whatever our final answer is. So negative 3 plus negative 6 is negative 9. And the absolute value of negative 9 equals positive 9. So let's move on to some graphing. So what I have here is the y equals the absolute value of x. Now you can also write this as the function that uses x is equal to the absolute value of x. At this point, y equals and f of x equals are pretty much the same thing. Well, we're going to go way back to the beginning of graphing, and we are going to graph with a table of x and y values. So inputs and outputs. So if we remember, my favorite inputs are negative 2, negative 1, 0, 1, and 2. Now you can use any inputs that you want. I like those 5 because they're the 5 smallest possible numbers that are non-decimal, non-fraction. So then we want to know, with these inputs, what is our output, or our y value. So what we do is we look at y equals the absolute value of negative 2, which is positive 2. That ordered pair is right here. Then we look at the absolute value of negative 1. That's equal to positive 1, and that's right here. And finally, the absolute value of 0 is 0, so we're right there. Now, if this was a line, we would probably just draw the line straight through. But since we're dealing with absolute value, we know that there has to be some type of turn or a V shape where we have to find that vertex. So what we do here is we then just do y equals the absolute value of 1, which is 1 because it has to be positive. And it looks like we found the vertex here. Then the absolute value of 2 is 2. So our vertex is the point 0, 0. And we are actually, it's kind of like graphing a line in opposite directions, like this and like that. Now my line got a little bit off there at the end. But we need to know when we're graphing an absolute value, we have to be able to find that vertex. And so our table has to be able to figure out where that is. So let's graph another. So when we are looking at this type of equation, we have y equals the absolute value of x plus 3 minus 4. Now we can set up our table just like we did before. -2, -1, 0, 1, and 2. But there is something that's going to end up being a little weird here. So to go a little quickly through this, I'm going to go -2 plus 3 in the absolute value bars, and that answer -4. This is 1. The absolute value of 1 is 1. -4 equals -3. For -1, we do the absolute value of -1 plus 3, which is 2. 2 minus 4 is -2. 0 would be 3. 3 minus 4 is -1. If we did 1 plus 3, gives us 0. And then 2 plus 3 is 5. 5 minus, oops, sorry, that should be a 4 here. And then 5 minus 4 is 1. And if we graph our absolute value function here, what we currently have is a line, which is not what we want. So it looks like on our absolute value equation, we have not found the vertex. So I'm going to give you a trick here, and this is going to be worth SPs. Okay? The vertex is almost always going to be creating a 0 inside of the absolute value. Okay? So what that means is we need the value of x that creates this thing to be equal to 0. And what that is -3. Because -3 plus 3 is 0. 0 minus 4 is -4. So on this side, we're going up in an angle. And if I'm right, that means if I take these negative values on the left side, it's going to create the line in the opposite direction. Whoops. So if we did -4, that'd be -4 plus 3 is -1. Absolute value of 1, or -1 is 1. 1 minus 4 is -3. This would be -2. And it ends up that we found our vertex. So for 5 SPs, if you come up to me and say, to find the vertex, you're trying to create a 0 inside of the absolute value parentheses, I will give you 5 SPs. Now, there's one thing that I want to do before we finish this video, and that's talk about domain and range. And domain represents all possible x values. Whoops, that is not how you spell values. All possible x values or x coordinates. The range is all possible y values or all possible y coordinates. The way that I remember that the domain is the x values and the range is the y values is I remember that x comes before y in this ordered pair and in the alphabet, and D comes before R in the alphabet. So my domain is all my possible x values, and my range is all my possible y values. So let's look at the two graphs that we made earlier. Let's look at the left graph first. This is y equals the absolute value of x. And the domain asks what are all of the possible x values that's used. Now I notice that this line's going to go on infinitely in the left side and infinitely in the right side, which means that every possible x value will end up being used. So we can write this two different ways. So we can say every possible x value, or the shorter way would be all real numbers. Most people will just say all real numbers. It means every number that's real that exists can be used as an x value. It doesn't mean it doesn't work. But the range is the y values. And I noticed that here is the bottom of my range. Nothing below 0 is used. Therefore, the y has to be greater than or equal to 0 for the range. So my x was all of the possible real numbers, and my range was only the y values that were greater than 0. For the one on the left, all of the x values left will be used eventually. All of the x values to the right will be used eventually. So my domain is still all real numbers. This time, the bottom of my range is here. Nothing below -4 is used. So that means the y value has to be greater than or equal to -4. And for absolute value equations, all real numbers is going to be your domain most of the time. Not all the time, but a large chunk of it. And your y value is the one that's usually more restricted. In the retake video, we'll go into a little bit more detail on that. But for now, if you have any questions, please let me know.